The broadcast is now starting. All attendees are in listen-only mode.
All right, guys, welcome back to another KevCAM night class tonight. Tonight have Steve Walsh helping out with any questions or concerns that come along the way. Steve, are you with us?
Evening, everybody. Thanks for your time tonight. Excited to show you a unique product on the market.
Yeah, and tonight we have kind of something special we've done in the past, but tonight we have Justin from Octopuz going to be showing us the ins and outs of how Octopuz works inside of SolidCAM and showing how it integrates in with SolidCAM and SolidWorks for you guys as well. And Justin, are you with us?
I am.
All right, perfect. And I do see some new names in here, so I'm going to kind of go through my night class ritual. So for those of you guys that are new in here, we use GoToWebinar, and what this does is it puts everybody in mute just to eliminate any background noise. But if you guys do have questions, there is a questions panel. Definitely type those in, and either myself or Steve will let them know that we need to, address that question, and we'll get those questions answered right away. And we'll also be doing a question and answer at the very end of the presentation for you guys as well. And for those of you guys that are new, we definitely, if you guys have ideas, send those over to us or send that over to me via email here. And I will put let me just put my email into the GoToMeeting chat so everybody has that. And those of you guys that are watching on YouTube, my contact information will be in the bottom, as well as Justin's from Octopuz, so you guys can connect with him directly. And last thing before I turn it over to Justin here is each night class that we do for you guys is being recorded. And if you guys go to YouTube and type in SolidCAM University or type in KevCAM night class, it will pop up, and we have almost 400 videos in here on how to do everything inside the software, including all the night classes as well. So if you guys want to rewatch kind of what we covered tonight, definitely come here and check it out as well. So at that point, Justin, let me hop it over to you, and I'll let you kind of take over and kind of show us how the Octopuz software works.
All right. Well, I really appreciate it. I want to thank Kevin and Steve for inviting me to show everyone a thing or two about Octopuz. Octopuz is an offline robotic programming software, and it's also a simulation software. Let me just start to share my screen, and I'll show you what I'm talking about. My plan for today is to take you through a very brief PowerPoint to give you a little bit of an idea of where Octopuz came from and what our expertise is, and a general overview of the software. And then I'm going to dive right into 3 different examples of how we work together with SolidCAM, as well as some applications that we specialize in. Specifically, I'm going to be focusing on milling, deburring, and welding, and then 3 different examples, one of each respectively. So if at any point you do have any questions, as it was said before, please type them into the question box below, and between Kevin and Steve, they will relay those to me once I stop to take a break or a drink of water. So I hope that you all enjoy. Again, if any of you are interested after the fact in a demo that maybe focuses on an application that I didn't cover, or on an application that I did, but maybe with something that you're currently doing or working on, or a project that you're working on, I'd be more than happy to connect with you and schedule something that's a little bit more tailored to what you're doing currently. So.
Excellent. And yeah, Justin, what he's going to be doing tonight for you guys is just kind of giving you a broad overview of kind of showing how Octopuz can kind of help you guys out, and the integration side of things. So like Justin said, if you guys are looking for more, let's say Ronnie, you want I want to see it in my application and my cell setup, then we can do a one-on-one with Ronnie and Justin for a demo as well.
Yeah, so just to give you a really brief overview, right off the bat, Octopuz in one form or another has been around in automation for about 34 years. We started actually on the CNC side of things, where we were building post-processors for CNC machines. So we're very aware of the industry or the work that most of you are doing right now if you're partnering with someone like SolidCAM. We saw a trend in the robotics industry that was very similar to what we had already experienced. And the way that now you'd be hard-pressed to find someone who programs their machines without software, we saw and continue to see a growth in the number of customers that want to use software in a similar way to program their robots, where they're going to save time and money in doing so. So robotic offline programming, for those of you who are not aware, really it's the ability to program your robot from a computer instead of having to use the teach pendant. This is going to save you time. If any of you have ever tried to teach a robot to do something like milling or welding or anything that's going to involve a complex toolpath, you know that using the teach pendant can be pretty cumbersome. So this is going to save you time, and ultimately it's going to save you quite a bit of money. Our software comes with something called multi-robot support. This means a couple of different things. It means that we support multiple different brands. I believe that right now we're up to 15 different brands that we can create robot code for. It also means that we support multiple robots in the same cell. This example is 4 Motoman robots that are hanging inverted, performing a water jet trimming application. I believe this is either for a tier 1 or a tier 2 automotive supplier. This is one example of robots communicating back and forth using digital I/O, and this is pretty common for us to see, and it's very easy to program. The software also comes with full error detection. This includes building a collision detector fairly easily. It will indicate to you, if you'd like it to, if you're moving through singularities, if you're running into joint limits or reach limits. I'll take this opportunity to tell you that all of our robots are built to spec based on information that we collect directly from the manufacturer. We partner with every one of the robot manufacturers that we host in our e-catalog and that we provide support for with a post-processor and the ability to create code. So if we ever run into issues, we directly deal with them. And if any new robots come on the market, or if an especially old robot is something that a customer is requesting, that is fairly straightforward for us to add into our catalog and start supporting. Something that I am obviously going to focus on today is our CAM integration. We support a number of different CAM softwares, but SolidCAM is special in the fact that we've created a direct link, one that makes it fairly straightforward, very easy to learn how to connect it. Or how to send information back and forth, and I'll demonstrate that to you today. Something else that is, I would say, one of the ways that we stand out is how easily we connect our robots into any external axes that you might have inside your cell. So whether that is, I'll actually be showing you something quite similar to what you see here, whether it's a robot on a rail or on a 2 or 3 axis gantry, whether it's operating with a 2 or 3 axis positioner, or in this case a headstock, tailstock, or any combination therein that you can imagine. We're going to generate code that isn't just 6 axis code, it's actually 7, 8, 9, 10, 11 axis code, or however many different axes you have connected to that 6 axis arm. We can support anything I mentioned and more. It really depends on what the project is. Something else, I won't necessarily focus on this today, but the other side of our software is factory simulation and the ability to perform statistical analysis, the ability to perform or generate a very quick simulation of a cell concept design, for instance. We partner with several robotic systems integrators, as well as some customers who are considering adding automation to their facility and are having a hard time visualizing what that's going to look like. Software like ours can make that process a little bit easier, and so it's interesting that quite a few of our customers don't even have their first robot, but they're already seeing the value of simulation and programming software like ours. So this is a list of some of the more popular applications that we see. I will be focusing, as I mentioned today, on deburring and milling, as well as welding. Welding actually makes up close to 50% of our customer base because, and again, I mentioned this before, it is one of the more complex applications that you can perform with a robot, and as a result, it's where the greatest return on your investment is going to be. The same can be said for milling and deburring or really any complicated toolpath.
And in the future, we'll have Octopuz taking over SolidCAM tech support, so the robot will be able to.
Oh, is that how it's going to work?
Yeah. No, I'm just kidding, guys.
So I already mentioned some of the advantages of why customers do choose us. We have some examples where customers are saving not just hours, but in some cases days programming an individual part. And for some of them, if they're high mix, low volume shops and they're really dependent on how quickly programming time is the major bottleneck for them. If you can go from a week to program a part to a few hours to program a part, and we do have examples and references of customers who've experienced that, it's a major paradigm shift, and now it frees up time to bring in a lot more business. And again, we have examples of companies who started to change the way they do business as a result of this sort of a solution. This is a list of some of the more popular CAD packages that we support. SolidWorks is certainly the most popular, but it is definitely not the only one that we see. And we pride ourselves for being flexible and easy to work with, regardless of what solutions or what technology one of our customers is currently using. Again, we want to make it as easy as possible for them to transition to using Octopuz. And this is a list of the brands of robot that we see most often. I would say it really depends on the application. In some cases, we see more FANUC. In some cases, we see more KUKA. And in today's demo, I'll be showing you two different brands. Again, it will depend on the application. Now, I believe, Kevin, I think you were saying that my contact information is going to be provided at some other point or at the end of this, but in case anybody wanted to write this down now, it's pretty straightforward. Yes, Octopuz is spelled with a Z on the end. I have to be careful not to say Z, or else everyone knows that I'm from Canada.
You already gave that away when you said process.
Oh, gee, okay. Is it process?
Yep, process. It's funny because we have Mark from our tech team on here as well, and he does the same thing, so I'd like to give him a hard time about that.
It's funny.
And one thing I just want to throw out to you guys is, for the night classes, we're not here to sell you on anything. SolidCAM, tech support, for a lot of you guys that have been dealing with us, especially in the U.S. division here, we look out for what's best for you guys in the, more than anything. We're not here to try to sell you anything. We're just trying to help you out in the final end game. So, there's several robotic companies out there that have approached us and said we want to integrate in. But looking at, Octopuz and the integration, and my biggest thing is how easy it is to use is huge for us. So, we figure, SolidCAM is very easy to use, integrated with SolidWorks, and really converts over to Octopuz as well. So, that's why I wanted to get Justin here and show you guys exactly, how this works, how it can benefit you guys, and how easy it is to actually use for you guys as well. So.
Hey, Kevin, before I get started into my first of three examples, were there any questions that popped up during or at the end of that PowerPoint?
No, I think no questions so far, so we're looking good.
All right, perfect. So this is, as I mentioned, this is going to be the first of three examples. This is going to be a deburring application. I've got a KUKA here on a pedestal, a two-axis KUKA positioner in front of it. The two are linked, so any code that I generate in this cell is going to be 8-axis code. It's also got an engine block part with a few tool paths, deburring tool paths that have been designed already. Now, this is a complete cell, and I say complete cell with an asterisk. It might not look like the cell that you have on your shop floor. I will point out that before any sort of integration or on-site work that we're going to do, we would be building up an exact virtual copy of one of our customer cells. Now, the reason I don't have one of those cells in front of me here is because most, if not all, of our customer cells are private and they're proprietary, and the same can be said for a lot of customer components or custom tooling that we work closely with our customers to build and to add kinematics and behaviors to. So everyone here can be reassured that any work that they do won't be, or any work we do for them won't be shared with the community of Octopuz customers. But also today, the focus was going to be on more of a stock demo. I mentioned it at the very beginning. If you'd like to contact me so that we can put together more of a custom demo, I'd be more than happy to do so. So in this first example, I'm just going to press play and show you what a moving simulation inside of Octopuz looks like. You'll notice that I've got my tool part, or my tool following my tool path. Tool path number 1, it's about to follow tool paths 2, 3, and 4, respectively. I can slow down or speed up my simulation if I like, similar to what you'd see for a simulation inside of SolidCAM. If I wanted to make a recording of this, I have a few different options. I can take a recording as a moving PDF document. What's nice about this as an option is that it's a very small file, makes it easier to email if you're an integrator, or if you're trying to communicate this to a customer or someone internally. It also allows you to move around the environment the same way that I'm moving around this environment. So it's very interactive, very easy to, like I said, interact with. And you also have the option of creating an AVI file. And new this year, we have the option of creating a virtual reality document. So more than just being able to move around the environment, you really get to experience the environment. Now, this is something that's actually on display next week with a couple of our partners at the IMTS show in Chicago. I won't do that right now, but if you're interested in seeing more about integrator tools, I'll be hosting an after IMTS webinar where we focus on this, among other things, with respect to what integrators or machine builders might be looking for. Now, one thing I want to draw your attention to, the first sort of the way that we can manipulate tool paths inside of Octopuz. If I select this first tool path here, and I go into something called the Schema Window, this is going to show me every point in that tool path that's come in from SolidCAM. So this particular tool path, out of the 4, I think it has 430 points. We can make changes to individual points here. We can scroll through. We can make changes to the orientation for one point or for the entire tool path. I can change tool speed. I can add tool I/O. I can turn a tool on and off whenever I like. And this is going to be the same experience that you have regardless of application, regardless of robot, regardless of where your tool path came from or how many robots you have in your cell. So what's nice about that is that you might have one robot cell that you hire Octopuz to come and calibrate for you, and that's what you're learning the software to program. But if you were to expand the way you use robotics moving forward, and you start welding, or you start painting, or you start using it for some of your material handling robots, anything that we've taught you can be applied to future applications pretty easily without the need for much additional training, if any, at all. So let's say I went to my first point. Once I start my path, and for whatever reason I don't like the orientation of my robot. Maybe maybe this joint here is getting a little bit too close for comfort to my part, and I'd like to reorient my robot. It's fairly straightforward. If I were to go into my jog tab here, all I need to do is make sure that I have object selected, so I'm rotating around my tooltip, and I can in real time move my robot around that joint or that tooltip, that object, to find a more desirable orientation. Now, what I really like about this, and that's another thing that's new this year, is we added a physics engine that allows us to do, among other things, cable manipulation and cable simulation. So if I were to turn on a collision detector, I actually get to see how my cable is going to wind around my arm. So, I mean, it's one thing that I've been told from our application team, that when they're on site, a lot of customers, when they start programming with a tool like this, cable wrapping is not something that it's a hard thing to wrap your head around if you're not seeing it in front of you. So that's why we added it to some of these robot arms. Anyway, if you like this new orientation, it's as easy as touching up a single point, making that point a reference point, and now applying that reference point and that orientation to all 430 points of my path. So now if I reset, you'll notice that new orientation is taking effect. And that's an adjustment, that's a manipulation that is going to appear in the code as is right now. If I was happy with this tool path and the changes that I've made, I could export this as KUKA code as is. Now, what's nice about that is that not only will it load onto your controller, but any adjustments you make on your controller. And sometimes you need to do a program shift, or you need to add, delete points on the fly. We also have the ability to import KUKA code, as well as a few other brands. And so any changes you make on the floor or on the pendant are completely compatible with the cell that we have in Octopuz. So it's very easy to move the work that you've done back and forth from the virtual world to the real world. Some of you might be asking, how do we ensure accuracy? That's something that we provide as a service where we come to site and calibrate your cell for you. But really what that is that we're going to take your base frame or user frame data from the real world cell, bring that into Octopuz and shift or realign any of the work that's been done virtually, which assumes that everything is where it's supposed to be. And we're going to snap it to that new user frame that we've taught using points from the real world cell. So usually it takes about a day per cell, sometimes 2 days, depending on how complicated that cell is, how many robots, how many external axes. Are there any questions based on some of what I just talked about? Because I did just cover quite a bit of information.
Well, one question I have for you, Justin, is how long would it take to program this, what you just did right there on the pendant, versus programming it in Octopuz? Because a lot of our customers kind of do the same thing as a lot of new customers, they'll hand code all their G code in there, and then they'll see the benefit of using SolidCAM. Can you give us the benefit of this one in particular?
This one in particular, it's hard for me to say because I'm only now just starting to play around on robots myself. But I'll give you an example. So to program this in SolidCAM probably took an average user. What would you guess, Kevin? I mean, to program paths like this would take maybe half a day.
Well, I wouldn't even say that long to do the deburring side, but if you were to actually program that from the pendant, are you looking at a good 8 hours worth of using the point-to-point pendant?
If this is a brand new program, I would say this is a data program at least.
Okay.
I would say it really depends on the user. It's tough for me to say. I'm sure that there are users out there, and we find customers that say that they could probably program it faster than we can program it. But the advantage that you have here is that we can the robot is, how do I put it?
Well,
I think it's the ability to program a brand new part from scratch and then do that process over and over and repeat that process over and over again. That's where you're going to see the return.
Yeah, and then that also benefit.
There are some applications where you don't see a return. I know that when we spoke last, Kevin, we were talking about machine tending. Machine tending on its own is not something where you're going to see a significant time savings if that's all you're doing. Now, if you want to simulate machine tending, that's something that we're more than capable of doing. But if you're looking at saving time programming and machine tending is all you're doing with your robots, it's something that you can do inside Octopuz, but that's not really where you're going to get the greatest value. The greatest value is going to come, and I mean, this is one example. If I were to open up, here, let's jump into cell number 2 that I wanted to show you.
And while you're opening it up is, you guys remember that, the robot can be running a part while you are programming a different part. So you guys, just like in SolidCAM, you guys can be programming in virtual while that machine is, running. And then we can go right from, there's no downtime where if you're programming off of a pendant using the robotics side of things, that cell is completely shut down while you are programming on that pendant.
I mentioned before some of our customers are high mix, low volume, and that sort of speaks to a problem that they run into. So they'll have one robot cell, and they'll have a job running on it, and that job might take a couple of days to finish, and in that time, you can't really do anything with that cell, that robot. You can't prep your new part. Everything has to stop when you want to make a change. In this case, it doesn't. In this case, production can continue, and the impact that has is exponential. Every time, if you have 2 robot cells, 5 robot cells, 10 of them, the impact is going to be significant. So, and that might be something that some of your customers are going to ramp up to eventually, but it is something that they should consider, that they get to make changes and make decisions quicker. And if those changes need to be made on the fly, they can be. And they can be made remotely as well. We have some customers that have multiple facilities, and they've maybe got 2 or 3 or a handful of programmers to manage all the robotic programming. And it's now, instead of having to send those programmers all across the country, they get to do it from a central location, and they get to do it quicker. So for this cell that I opened up, this second cell, it doesn't have a part in it. This is more likely where some of our customers would begin. So we will set up their cell for them, but let's say they want to program a brand new part. So this is an example part that came out of the, I think there's a templates folder or an example folder inside of SolidCAM. So this is a blade part. I like blade parts because they help me demonstrate coordinated motion. They help me demonstrate like a curved 5-axis, like a very complicated toolpath. This is something that would be very difficult to program a robot to do by hand, I believe. This is not something, if we had a customer asking to do something like this, I would not recommend that they do it manually. I would strongly recommend that they consider using a CAM software. And if they're already going to be using a CAM software to program the path and doing all the heavy lifting inside of CAM, why not use a robotic programming tool that interfaces easily and is going to help you leverage the comfort that you have in whatever CAM software you're using. So for those of you listening, I'm assuming that you're using SolidCAM. Why go to the trouble of having to learn something new when you can continue to do the work using the software that you're used to, click a button, and now really all you're doing is transferring that work you've done in CAM and then converting it into whatever robot code you need. So in this case, I've gone through and taken a couple of steps that we would do for you, or between our team and Kevin's team, we would do this for you. Is we would set up the Octopuz machine, and in settings, we would set up whatever template cell you want to drop this into. So in this case, I built this cell ahead of time, and I built it to include a SolidCAM frame of reference. So when my part comes in, it's going to snap to that positioner in a predetermined location. This is exactly how we would set up a real cell with, let's say, fixturing or tooling that is going to house whatever part you were machining. And that part in the virtual world is going to snap to that tooling exactly the way it would in real life. So now under operations, all I really need to do, I'll show you just for reference. I'll click simulate just so you can see what this, what this toolpath looks like. Slow it down a little bit. And this milling toolpath, I'm just going to be bringing the one over for simplicity's sake. I'm going to right click on operation. I'm going to go to G-code simulator, select Octopuz export. I have a few different options here. I'm going to be choosing all data because I already have the cell open. If I did not have the cell open and I click all data and run simulation, I believe it would open up an iteration of Octopuz in that cell and snap the part to that frame that I already created. And that frame is going to snap to, as you can see in here, the origin of this part has been moved to the base, and that's what's going to snap to my frame. So now it's going to sync that toolpath, and once it's complete, I will show you how we import that inside Octopuz. I'm going to select my robot. I'm going to go to my Program tab up at the top, and I'm going to select Import Commands. Now, Import Commands has a drop-down menu, so we can do two things from this sub-menu. We can import a toolpath, and we can also import backups. I mentioned before that we are able to import KUKA. We can also import FANUC, Universal, Motoman, ABB backups. So any work, this is important to note for anybody who already has a robot. There are going to be programs that just make more sense for you to write manually. Something like a tool change program. It's very simple, and it's going to be something that you use every day. For brand new programs, brand new jobs, it's very likely that you have a cell where you need to execute a tool change several times over. So instead of having to redo or rebuild dozens and dozens of small manual programs, as well as being able to import the user frames and the tool frames that have already been built on your controller, we're able to import all of that data. And it's very much a part of our onboarding process. So when we're preparing to deliver our service to a brand new customer, we request that they send us a backup, a new backup, of any robots that we're expected to calibrate. And from that backup, we're able to take, as I mentioned, the user frame, the tool frame data. We're able to take all of the programs that have been written, and we're able to see examples of the code that they're working with. So our post processors are going to generate KUKA code, but that KUKA code is going to look the same for every customer. And I'm sure anybody on the phone that uses a KUKA or does any programming with a current robot knows that everyone's code is going to look a little bit different. So that's why we like to see a backup ahead of time, so that if we need to make any tweaks to our post processor, we will do so that the code we generate and the code that you generate with Octopuz is the sort of code that you're familiar with and the sort of code that is going to work with your systems. So if I select import toolpaths, you're going to see the toolpaths that I brought over. If I click accept, that part and path should snap to the frame that is attached to my positioner, and it does. I'm going to take a couple of additional steps. When I go back to my home tab, I'm going to make sure that my part and my fixture are attached to my positioner. So I'm going to click attach, and now it's parented. Both of these components are going to be parented to the top piece of my positioner, which means if I interact with my positioner, they should rotate at the same time. And if I create any sort of a user frame on this part, it's going to be a dynamic user frame that is going to move if the part moves. I select my robot again and go into program. I'm going to press play, but I'm only to demonstrate to you that right off the bat, this robot is operating in a less than desirable orientation, obviously. We're going to run into problems with cable wrapping, but more importantly, we're going to run into a collision very likely, or a joint limit. So, as I showed you with the previous example, if I were to jump in here and I want to jog around my tool, you'll even see here that I'm running into a joint limit on A5. I'm going to open up my Schema window, as I showed you before. And I'll demonstrate this to you using our externals. I mean, I have a 2-axis positioner. I might as well use it. So in this case, I'm going to rotate around my tool to a more desirable position. And I'm going to click Calculate the External Rotary Tables to maintain this current tool orientation. So this is going to open up a rotary settings menu. I have a couple of different options here. I can keep my tool tip direction. I have a few different options on how to orient my robot moving forward, utilizing the 2 additional axes of my positioners. So I'm going to have it orient with tool tip direction. I'm going to turn tool twist on. I'll make sure that this goes back to where I wanted it. And I'll click accept. And now you'll notice if I play through my simulation that my orientation has changed, and if you look closely, my positioner is engaged. Doing something like this manually, especially for someone who is maybe not so familiar with the part, if it's a brand new part, there's a lot of trial and error that's going to be at play. We try to eliminate most of that by allowing you to program using this tool. And we also try to eliminate a lot of the touch-up work that needs to be done after you program using this tool by providing the service of calibration ahead of time. We have customers that say that they will spend just as much time programming as they do touching up that program after the fact, and we try to save you time on both sides of that equation. So we try to save you time up front, programming a new part, but we also try to make it so that once that part is programmed in a cell that we've calibrated, really there shouldn't be any significant errors that pop up. And if there are, you have full access to our Octopuz support team, as well as, and I'll show you here, I'll jump out of the software really quick. If you go to our support site, you'll notice that not only is this where you download a copy of the software, but this is also where our knowledge base, which is full of documentation about all the different ways that you can use Octopuz. But this also houses our Octopuz Academy, which all of our customers on maintenance, as well as any trial customers, have access to. And this is full of videos of all the different ways that you can use the software. So this is full of tutorials that are a little bit shorter, and even full courses on everything from welding to pick and place to painting. And all of you are more than welcome to reach out to me if you'd like a short trial of the Octopuz software, and you get access to our Octopuz Academy at the same time. Are there any questions now at this point, Kevin? Have any come up?
Looking good so far.
Oh, good. I hope that's a good sign.
Yep.
So
usually this crowd is quiet until the last second, then they'll start popping up. I'm just waiting for Ronnie's question to come up.
Well, listen, if you were happy with the work that you've done on this KUKA, I mean, if you wanted to set up a collision detector, you could do that here. I'll show you that really quick. So I can create a detector. All I would do is select my robot, side A, select my tool, side A. And I select my part, side B. I can set up a tolerance if I like. Pretty simple.
And this is pretty much,
if I wanted to create a program,
what Justin's showing us right here is pretty much the same thing as you guys have seen me set up with gouge detection with HSS. So nice.
Oh, so you guys have something similar?
Yep.
Oh, good. If you wanted to create code, it's going to recognize that this is a KUKA program or a KUKA robot. In some cases, it's not always the case. In FANUC's case or ABB, we really only have one option for creating code. In KUKA's case, there's a few different options. So depending on what you're doing, it might make more sense to create a .src and a .dat file. That's going to ensure that you have that additional detail that a KUKA is able to generate. So for any sort of especially fine machining or applications that really require the accuracy that a KUKA provides, and usually with machining, that's what we see are KUKAs. The addition of, I believe it's the .dat file, is going to include some of that more fine detail. Oh, and this is a little bit of a larger program, so this might take a minute. The next application that I'm going to show you, I'm going to jump away from machining and start to show welding. So I will ask if there are any machining questions that we try to focus on those right now and get those out of the way really quick. Otherwise, I will jump over to welding in just a second after I show you this code.
Ronnie's asking, is it mostly 5-axis path that you guys are using with the Octopuz?
No, you can bring in whatever path. If you have a 3-axis path or 4-axis path, you can bring those in as well. What happens is any work that you do in CAM is going to be converted into an intermediary file format, regardless of the number of axes that it's been designed to utilize, and it's going to be converted into 6-axis code. So we get that question once in a while. So if this is how am I supposed to program a 6-axis robot if I'm only doing a 2-axis DXF? If I have like a 2-axis DXF file that I'm doing for dispensing, let's say, even that's going to be converted into 6-axis code. So you don't, and that's all going to happen behind the scenes. You don't have to worry about that.
Perfect.
Okay. I think this might be because I'm on Wi-Fi in the conference room that I'm in, so I apologize about the bit of a delay.
Oh, you're all good. These guys are used to seeing long calculation times.
Well, I've talked it up quite a bit, right? So I better be able to produce something. Otherwise.
And then one more question here for you, Justin, is using a lesser axis process, would it make the prove out easier if it was smaller amount of axes?
What do you mean? What do you mean by prove out?
Ronnie?
The code, I think, maybe, right?
Maybe. So sometimes the calibration step for us, what's jumping? All broke it up into a lot of little programs for whatever reason, but so that's an example of the KUKA code. I don't know if anybody listening is especially familiar with KUKA code, they can take a look at this just to verify, but I would say that KUKA is one of our better relationships. That's not to say that we don't have strong relationships with all the manufacturers, but we do a lot of work with KUKA and FANUC.
And then one other question for you, Justin, too, is if you had a dual head robot, are you able to program both robots all within the one program, or do you have to create separate programs and kind of copy and paste them together?
It depends on the brand. I know that our engineering team, if I ask them that question, and I have, their response would be, show me an example of some code, and then it would be a case-by-case basis, because it really depends on how it's currently being structured. And some brands structure it very differently. And some brands have different ways, like they have different, I know Fanuc, there's a couple of different ways it will appear. But if we're talking about 2 robots or more on the same controller, that's, the safe answer is it depends on the robot. It depends, it's going to be on a case-by-case basis. But yes, it is something that we have supported in the past on certain projects. In some cases, we've had to do a little bit of custom work. In some cases, it's going to work right out of the box.
Sure.
So
and I know we kind of went over this once before with Alec Industries, but with your Kuka robot, having a multi-head clamping fixture. So let's say you had your part holding right there, and you were deburring the one side, and then it would kind of rotate the robot head to grab a clamp, flip the part over, and then go back to the deburring process. That's something that can be done inside with you guys as well, right?
Oh, that's even simpler. So 2 robots on the same controller is case by case. 2 different tool center points or 2 different tools on the same housing on the end of the arm is pretty straightforward. So you would, I don't know all the ins and outs, but that would just be a matter of having two different tool frames set up.
Yep.
And then what you would do is, I wish I still had that open. You would go inside of your Schema window and you would just instruct it to, you would choose a different TCP for that tool path. So if you had 4 or 5 different tool paths come in from CAM, one of those tool paths was a deburring path, and one of them was a polishing path, let's say. And they're using 2 different tools on the same housing. Instead of doing a tool change, what would happen is you would just change what the TCP was for tool path 1 and tool path 2. So maybe with an error move in between, but it would solve itself. That would be very straightforward.
Perfect. And one real big eye opener, for those of you guys that are listening right now, is the really cool thing about with Octopuz is, we're able to, take that cycle time, and let's say we had a 15-minute cycle time and it's doing some engraving, it's doing some deburring all in the machine. Well, now with Octopuz involved here, we can have, maybe a 8-minute cycle time. And then while that 8-minute cycle time is going on, the robotic, the Fanuc is doing the engraving and the deburring outside the machine. So you really get more parts per hour, because you're able to shorten that machine cycle time by that much more, because that robot is, doing some of that secondary work outside of the machine for you guys.
So one last, the last thing that I wanted to show you guys before we run out of time is a welding demonstration. Kevin had indicated that there are a number of customers that might be interested in seeing this. It is one of the more popular applications that we have and that our customers utilize the software for. There is a lot that you can do inside of welding. I'm going to do my best to show you some of it. And again, I will reiterate, if there's any interest or any questions or anything after the fact, please feel free to reach out to me. It might be easier to have an offline discussion about, specifically if you're doing welding, because that might take more than a couple of minutes. So in this case, I'm going to pull in a couple of components, because for this welding demonstration, I actually wanted to show you how I would build up a cell from scratch to show you how different pieces fit together, if they've got PMP behavior built into them, how different components are parametric. We build a lot of our components to be parametric so that you can mess around with not just the geometry in some cases, but with the behavior in other cases. So in this case, I'm going to, from a drop-down menu, select the size of my rail. Let's say I want this rail to be 5,000. Yeah, 5,000. Then I'm going to select a Fanuc robot. In this case, I'm going to select, I believe, an M710 long arm, 12L. And you'll see when I pull my robot close to my rail, a green line, which indicates to both have PMP behavior or pick and play, or plug and play capability. So they're going to snap together. The two bases or the two origins are going to snap together. We can build new components for some of our customers that have this same capability, and we do that often. You'll notice the same thing when I bring my Binzel torch in, when I bring it to the end of my my joint 6. Oh, I did that a little fast. If I bring it to the end of my joint 6, there's a green line and it snaps. So the next piece I'm going to bring in is a headstock tailstock. And drag that into the world.
And what Justin is doing is basically doing like a machine sim, kind of like what we do for all you guys that are currently on the GoToMeeting. But look how much easier it is with the drag and drop.
So now I'm going to select my robots, and I'm actually going to select, so there's something that you can check off called interfaces. This is going to show you how we link the robot to an external. So it's actually going to represent the physical connection that you have in the real world by drawing a line between the robot and the positioner. And now that the positioner is green, I know the two are connected. So I'm going to deselect that. So now, any programming that I do is actually going to be 7-axis code. It's going to, or more than that, it's going to be 8-axis code. It's going to be the single axis of the rail, the single axis of the headstock, tailstock, and the 6 axes of the FANUC robot. The next thing I'm going to do is I'm going to bring in the geometry of my part. So I'm going to import geometry from here. I'm going to go to Documents. I'm going to search for weld beam. Once that part comes in, I'm going to align, so use a tool called Align, to align this with my positioner, and then I'm going to parent it to my positioner. So if I go to Tools and Align, I'm going to select the center of that, snap it to the center of that. I'm also going to click Attach to my positioner. And a good way, an easy way of testing whether or not that has worked is if I go to Interact, as I did with one of the previous demos, and I rotate. And actually, in this case, I needed to make my positioner a little bit larger. So I'll do that step over again. Line.
Now, Justin, as you're aligning these, does the 3D connection mouse work with Octopuz?
The 3D mouse does work, yes,
Okay.
that is correct. I already parented it, so that's what. There we go. Good. Now, the only thing I'm going to change before I start programming is I'm going to go into my Weld tab, and I'm going to jog my robot's, my J5 joint out of singularity. I'm going to select a base frame. In this case, it's going to be base frame or user frame 1. And if I select this cube here, it allows me to select geometry to attach that frame to. In real life, we would define that user frame on the pendant in real life, and then we would take that data. If you look here, these values are the world values for that frame. Any work that we do in Octopuz can be shifted to be accurate to whatever is in the real world by adjusting these values. So if we taught 3 points, for instance, on this part at 3 corners, and that frame ends up being, I don't know, another 200 millimeters in the Y direction or in the negative Y, we would adjust that here. And any work that we've done in Octopuz would then shift. You'd see that frame and all those, that program shift in that direction. And I'll show that to you in a second. The other thing we're going to define here is the TCP. Most of our tools have a predefined TCP, as you'll see here. And we should be ready to rock. So I'm going to save state. Now, It's pretty simple to weld. Once I have my robot selected, if I hit Generate Weld, this is going to open up my welding add-on, and there are quite a few different parameters that you can change here. If I load my defaults, you'll notice that I've got all my start values, my end values, and my full weld parameters that I can change. So my torch, twist, and tilt, my push, pull, I can change that here. It's pretty easy to do. If I go into search, I can add a touch sense routine if I like. Depending on the brand, we support really whatever the brand supports. So if it's enabled on your controller, it's something that we can program for. So in the case of FANUC, we can do a 2-point wire search if we like. We support stitch welding, we support weave welding, seam tracking, circle support. We support multipass welding. In the case of multipass, we don't see it all the time, but when we do see it, our customers appreciate the fact that they can select and manipulate individual passes. So if they want to add offsets, if they want the length of different welds or different layers to be different, they can make those changes very, very easily here. And the data that they have on their controller, if they make those changes manually, again, I will reiterate, will come into Octopuz when they reload that code. Smart Weld allows us to go around curved or imperfect geometry. And then in the positioner and track tabs, it allows me to interact with both of those externals. So what I'm actually going to do is I'm not going to select any of those. If I were to generate a weld, I'd hit create weld, and it would allow me to select surfaces. It would create a seam, and it would create a weld program. But instead of doing that, what I'm going to do is I'm going to select quick weld, and to demonstrate one more thing to you. Quick weld is a way of accessing any recipes that we've written in the past. So in this case, I've written a SolidCAM test recipe. If I select that, I actually get to skip going into the weld add-on, and all I have to do is select a start surface and a floor and a wall, and Octopuz is going to do the rest based on parameters that I've already written ahead of time. Now, this is an excellent way of demonstrating how we save time specifically with welding. So in this case, the program that I had written before, or the parameters that I had changed before, include a touch sense, a 2-point touch sense. And you'll notice when I press play that this has turned on my positioner to keep my torch facing with bisector at a 45-degree angle for the length of my weld. If I wanted to, let's say, repeat that weld on the other side, I go to quick weld again. All the way. That's strange.
Steve, you were saying how good you were with welding. I wonder how it would stack up against the robotic welder here.
Yeah. I'm putting my money on the Octopuz welding. To be honest with you, been a while since I've had an old. Yeah.
Search good. My track should be on for this one. So we restart. I'll speed this up a little bit. Once again, this is code. This is real code that we can generate and plug into our robot right now if I wanted to. In this case, it's going to pick up the fact that it's a FANUC robot. It's weld code. And all the different parameters that we changed, including the coordinated motion. So this is going to, I'll actually show you. If I click weld post, and SolidCAM, save it as weld program, rewrite. This is that FANUC weld code that we just generated. Now again, I will reiterate that this cell is not calibrated. It's something that I just designed here, but this is very similar to the process that our team goes through to build up the virtual copy of a customer's cell. Really the big piece that's missing here is importing the backup, which we can do here. And when I import the backup, it's going to give me the option well, it's going to look for a backup, which I don't have. But I select info. It really wants to open up a backup. So if I were to import backup, it's going to give me the chance to bring in all of my limits, all of my frames, my tool frames, my user frames, and then we will, actually, I'll show you an example of what we would do.
So I guess the main takeaway from this is, just showing you guys how easy this is to use. He went from, Justin went from nothing there at all to having a robot to the part with the indexer and the weld head on there within, I think we're 8 minutes in?
Something like that, yeah. One more thing I wanted to demonstrate before the end of this is, let's say you did programming for a part where you put hours, if not days, into doing some offline programming, and you find out that maybe your geometry is not as perfect as you thought it was, and some changes needed to be made to your user frame or your tool frame, and you were afraid that you'd have to redo all that work. This is sort of to give you a preview of what it would look like once we calibrate a cell. So if you've done some of this work, which we will do ahead of time to help prepare for our on-site work. If I went into U-frame 1, and let's say instead of negative 11,000 roughly, let's say it's negative 11,500. I want you to pay attention down here. Look at this toolpath. When I click enter, this toolpath is going to shift. That's a pretty significant shift. But let's say that your positioner got moved, or your rail got moved, or something shifted on the floor. Instead of having to redo this program, all we really need to do is redefine that user frame, which is one thing that you need to teach on your robot. And once that's taught within a reasonable degree of accuracy, which is going to be determined by your tool, your TCP values. Once that's been done on the floor, you can import that data into Octopuz, shift your program however is necessary, and then re-export this code to be accurate based on the work that you've done on your cell. So once you get comfortable, and then keep in mind that I'm not one of our sales engineers. I don't do this on site, but the concept is pretty straightforward once you wrap your head around user frames and how that data is being taught. A lot of our customers hadn't taught user frames in the past, but I will tell you that moving forward, they find that it is a great way of ensuring accuracy, especially if things need to be changed. And it's a great way of conserving that time they've spent programming offline so that they don't have to redo any of that work once changes are made. So, Steve, Kevin, I apologize that I didn't leave 5 or 10 minutes here at the end to answer questions, but I am more than happy to stick around for a couple of minutes and answer any questions that do come up.
No, you're good. One did come up though is, right now you are doing like a weldment off of, physical SolidWorks geometry. Are you able to do, a weld line off of just like a simple sketch line?
You mean like a 2D, like off of like a DXF? Is that what you mean?
Yep.
We should be able to do that. I mean, like there's no reason why we wouldn't be able to. In this case, I'm selecting, what's happening when I select a floor on the wall is Octopuz is creating this seam based on where this surface and that surface interact. One other thing that we can do is outside of welding, inside the program tab, I can create, I didn't really highlight this, I can create just point-to-point movements, linear motion, and I can also create a path statement. Path statement is going to open up a separate menu on the right-hand side, and this is going to allow me to select edges, right? Not just seams, but really anything that's an edge-following path. So if you're doing something relatively simple, you don't necessarily need to do it inside of SolidCAM. I would say SolidCAM is where, if you're doing anything complex with surfacing, you're going to have to do it in SolidCAM. But if there was an edge that you wanted to weld for that, for whatever reason, you didn't want to use the welding add-on, you could select that edge, manipulate it however you see fit, and then generate the code for just this edge. And you could you can do manual welding and turn your arc on and arc off separately if you like. Sure. Sometimes we see that if people are doing spot welding, we see that where they want to it's more of a manual process with spot welding, but I hope that answers the question.
Yeah, absolutely.
There are ways to do it.
And I don't see anybody else have any other questions here for Justin. Ronnie, you got to have at least, a couple more. Come on. Justin, Ronnie's one of our great customers I like to pick on all the time, so he's my pick on guy.
He's your pick on guy?
He says he does, but no, I think it's great. Now, are you guys solely based up in Canada for the U.S. division as well?
Yeah, so our team in Waterloo, Ontario, is focused on supporting our U.S. clients. Everywhere else, we run through resellers. So in Europe and in Asia, we run through. We have integrator partners, resellers that manage our customers there. So all of our application engineers, all of our developers, and our sales team here in Waterloo are focused on supporting our U.S. clients.
Awesome. And that's kind of go to the same point as we do is, for those of you guys, using SolidCAM, you guys, you contact us at direct. There's no, reseller in between. So that would be the same case for, if you guys were looking at for Octopuz, you guys are dealing with Justin directly or part of his tech team directly and not working through that reseller for the U.S. and Canadian division. So.
Yep, and our application engineering team is the same. So it's one team that will build your virtual cell. Same team will go to site and do cell calibration. It's the same team that provides technical support after the fact or during a trial or in the midst of implementing a project. So what's nice about that is continuity. If you call in with a technical support question 6 months into using this, there's a very good chance that we can either put you directly in touch with someone who you've worked with before, or they're going to be a very close colleague or teammate of someone who very literally deployed the project for you. So it's I don't think very much gets lost in translation for most of our customers, which makes for a pretty smooth, pretty seamless customer support experience. So what I stress my customers to do, even at the very beginning, is take the software out for a trial run. Take it for a 14-day trial run. What's the harm, right?
Yep.
And what I like about that is that you'll have full access to our support team, to our, to all of our resources available online. And if they want, a lot of our customers choose to pay, a little bit for half a day of training. It really helps them get the most out of the trial. And the support and access to the online material. What's nice about that is that I almost want the customers to get stuck, because then they get a feel for what the tech support part of the experience is going to be like, and I think that helps define what the real world exposure, like what it's really going to be like, right? Because not everything's going to be perfect, not everything's going to line up. You're going to run into problems, and when you do, you want to be sure that you're working with the team that's easy to work with. And so in that case, I think it's one way that we stand out, and the best way to see that firsthand is to try us out.
Yeah, and that's kind of where we take the same, customer service as like what you guys do, and hence why we kind of, partner with you guys is, they use GoToMeeting just like we do. You get, somebody on the phone, you call, you'll get that, that tech person on the phone in a GoToMeeting and being able to see exactly what's going on. So, you guys will see a lot of the same characteristics as what we use on our support side. And Justin and his team have a fantastic team and getting you guys up and running with that as well. So, and this is by all means is not a sales pitch. It's just a tech nerd being excited about another piece of technology out there. So.
Well, I will speak for myself and say that this whole thing was absolutely a sales pitch.
Oh no, this is all technical here.
Hey Kev, there was a question that came in about how accurate accurately
Yeah, what is your accuracy with those robots? What are you guys getting, like plus or minus? Let's say just like on.
You mean like for when we generate code? You mean?
Yep.
So so the accuracy of anything you do in Octopuz is going to be determined by the accuracy of your robot. So if your robot has not been mastered properly, there's no way for us to foresee that, and there's no way for us to, like, if we request that it be mastered before we go to site, but that's one reason that we request a new backup, is because it helps us to validate that it has been. When you teach TCP on your robot, our engineers ask that you have an error that's less than 0.6, if possible. I will tell you that, and I'm not a programmer, but my first time out trying to teach a TCP, I realized very quickly that under 0.6 is difficult to do. But it's difficult to do for a reason. We ask that you spend the time to minimize that error as much as possible, because if you have a good TCP, it means that the user frame that you generate is going to be as accurate as possible. And when we import that data and we shift our program, again, it's going to be as accurate as the work is that you've put in ahead of time. So a lot of the time that we spend on site is actually walking through some of those steps with our customers. It's not just us doing it for them, but it's showing them best practices. I mentioned before that a lot of our customers don't really use user frames. They teach with dependents, so they put their robot where it needs to be, they teach that point. Then they put their robot where it needs to be next, and they teach that point. But for complex tool paths like this, user frames are essential, and we can certainly help educate, and we're more than happy to help educate our customers on how to do that in the best way possible. So accuracy, the answer to the accuracy question is we work with our customers to promote best practices in terms of creating TCPs and user frames that are as accurate as possible on the robot, and that is what ensures that the work we do and that they do in the virtual environment is as accurate as possible. Does that answer the question? Yeah,
pretty much what you're saying is you guys will be just as accurate as what the robot can be.
Yes. So if, I mean, same rules are going to apply whether you're using offline software or not. So if you've got, I mean, we're going to be entering center of mass data into the software as well. So if you've got a really heavy tool and your robot, so I'll show you. If you're, here, let me take this positioner, and I'm going to move it. Let me see. Or maybe that's not a good way to represent. Yeah, so if you're stretched out like this, obviously the further away from your base you are, the more variability that you may experience, especially if you've got a heavy tool or a heavy payload. So that point by a couple of millimeters here or there, that's not an issue with the software. That's just the nature of the physics of the cell and what you're trying to do. So same thing goes for your TCP. If the error on your tool center point is 3 millimeters, then we are accurate to within 3 millimeters. When we generate code and we put it onto that robot, it's going to be accurate to within 3 millimeters. And if it's off by 3 mil, that's not because the software is off. That's because the robot wasn't mastered accurately enough. Does that make sense?
And when you say mastered, do you mean like calibrated accurately?
Mastered, I believe mastered means a couple of different things depending on the brand. I think, and it's tough for me to speak on that specifically. So mastering, I believe, is making sure that your joints are rotating at correct intervals.
Okay.
I think that makes sense. That sounds about. So that's mastering, and then calibration. So there's mastering, and I would say teaching a good TCP. So the the way you teach a TCP, depending on the brand. So we have so I taught a TCP on as part of a training here last week on a KUKA, and on that KUKA, what you have to do is you have to teach at least 4 unique orientations of the tooltip at a specific point. So if you've got something like some sort of geometry on your part, let me think of, like, you want something that's going to come to a tip on your part. So a lot of the times, it doesn't really matter what it is, but you're teaching some point in space 4 times in 4 different unique orientations. And the closer you can get to that point, the lower your accuracy is going to be. And once you define that TCP with at least a 0.6 accuracy, or 0.6 error, that means that anything you program your robot to do in the future with that TCP is going to be, and if you take that program and you want to repeat it over and over and over again, it's going to do that within a margin of error of 0.6 millimeters. That's the way that works. So then you're going to take that TCP and you're going to teach a user frame. And a user frame is similar, but what you're doing is instead of teaching 1 point 4 times, you're going to be teaching 3 points. So you're going to teach, I don't know, this point, and this point, something like some 3 points. And that data is going to create a frame, your X, Y, Z in different directions, and you're going to import that data into Octopuz. You're going to notice up here that you're going to have an X value, a Y value, and a Z value relative to the base of my robot here. And if those values are different, you're going to input the values from the real world cell, and you'll see your program shift the way that it did here. And the more accurate your TCP is, the more accurate that user frame is going to be, and the more accurate that the data then that we generate with that user frame is going to be when we run it on the robot. Does that make sense?
Absolutely, yeah. Perfect.
So a lot of the accuracy issues are something that the more you do this, the more comfortable you are. A lot of our customers are already familiar with offline programming, are already familiar with user frames. They pick that part up a lot faster. The user frame thing can be difficult to wrap your head around if you haven't done them before, but I guarantee you that you are going to get a better result, and you really are going to save time in the end if you spend the time to learn how to do them. And when we're on site, we take the time to show our customers, like I said, best practices.
Oh, excellent. I don't see any other questions coming in here. So anybody else has any questions, definitely write those in right now. But as we kind of wrap up here with Justin, anybody that is viewing this on YouTube, I'll have his contact information in the description of the video. Anybody that is looking for his contact information right now, just shoot a message over or shoot me an email, and I will definitely pass that information on, or it's right on the screen right here for you guys as well. So definitely feel free to reach out. And I know, Ronnie, you had some questions that, would take up a little bit more time. So definitely shoot those over to Justin, and he'll get those answered up for you guys.
And if you guys have, if you're curious, we've got a YouTube page as well that's going to have a few different examples of applications and case studies and some of the new features.
And do you want to bring up that YouTube channel real quick?
Wait a second, I wonder if it's on.
Put you on the spot, sorry.
Yeah. All right. Yeah, so what are some examples? Like this is, let's see. I mean, this is an example of UR custom tool that we built for UR and some dispensing that we do for them, or that we did for them. This is an example of milling, edge following, additive. AccuMetal was a Panasonic case study that we did for welding. So yeah, that's
perfect.
See lots of examples on there.
Yeah, so if you guys just type in Octopuz Robotics under YouTube, you'll find Justin and his team's YouTube channel as well. So, but like I said, always, guys, for those of you guys that are listening live here or on YouTube, shoot us an email, give us a call, let us know what we can do to help you guys out. Especially on the robotic side, Justin is here to help you guys out. And on the SolidCAM side, myself and the rest of the SolidCAM team is here to help you guys out in any way. And really, the main point of having Justin on here is, we're partnered with Octopuz, and you guys can see the integration, how well it works back and forth. We feel the support is there, just like what we offer for you guys as well. So it's all around good bundle package. So I don't see any other questions. So, Justin, I just want to thank you for the time tonight and showing us what Octopuz can do for customers out there. And I know Ronnie's definitely thinking about getting a couple, but
well, you know what? I hope some questions come in later. Thank you very much for having me, Steve and Kevin, and I look forward to maybe getting some, like I said, some customers reaching out that might be interested in seeing a little bit more.
Yeah, and like I said, this is just a very, small piece of the pie of what Octopuz can do for you guys, just like when we show a SolidCAM, a very small piece of the pie. So if you guys are interested in, the Octopuz, definitely Justin would like to set that up one-on-one with you guys and kind of go over, maybe some pain points that you guys are going through with robotics, or what the robotic can add, do value added for you guys as well. So for that more custom one-on-one demo, that's what he's there for. So, but anything else, Justin, before we wrap her up here?
No, nothing on my end. Hopefully I showed you everything that you guys wanted to see, and just thanks again. I appreciate it.
Yeah, absolutely. Yeah, it was great to have you on here. I appreciate the time, and I know it's late, but we'll definitely get a lot of good interest here, because there's a lot of eye-opening stuff here. So, Steve, anything else before we wrap her up here?
No, just one thing for the group, Kevin. Justin, I think you mentioned you're going to be at IMTS. I'll just throw a little shout out. We're in booth 134523. Justin, do you know your booth at IMTS off the top of your head?
Oh, I sure don't.
All right. Suffice to say, you'll be there, though, correct?
I will be there somewhere.
I think you can just go straight to the IMTS website if anybody would like to stop by and check out Justin and his team at the show. So yeah, we're looking forward to it.
I think that we have a LinkedIn page that is probably going to have some information about our trip to IMTS, like where exactly we're located, and we're also going to be at a couple of partner booths as well. So you know what, if any of the people listening in have time and they're there and they run into us, that'd be great.
Yeah, and then if anybody's listening still as well, we are doing a customer appreciation night Wednesday night. I'll take you out for beer and pizza. If anybody is interested in that, including yourself, Justin, let us know and we'll get that set up. So how many different tap beers they have on there? Was it like 68 different tap beers or something?
I think it was, Kevin. Yep, definitely.
and non-alcoholic as well. So if you guys want to come there for a pop and pizza, we'll be hosting that event as well. And like I said, I'll be doing a tip of the day, kind of letting you guys know about that event as well. But contact your account manager if you guys would like to attend that. So, but with that being said, we're a little bit past, but thanks for everybody for taking their time on a Tuesday night to watch this Octopuz demonstration. I think it was fantastic, and we will be taking a short break just for IMTS with the night classes and even the tip of the days, just because IMTS and the huge rush that's going on with IMTS right now. So we will not be having a class for the next 2 weeks, but then after that, we are actually going to be going back to that part that we were looking at with Danny from Artisan's part on doing machine setups and using sign plates and all that stuff for you guys as well. So we'll get that scheduling on the website as soon as possible for you guys. But like I said, we are going to take just a brief break so we can get IMTS squared away for you guys. So, but with that being said, guys, have a great, wonderful night. And if I don't talk to you guys in the meantime or at IMTS, we will talk to you guys in the next night class. All right. Thanks, guys.
Sounds good.
Here, guys.
Thanks, Kev. Yep.
All right.
Thanks, Justin.
Wonderful.